This question starts just confirming that I and j are unit vectors and the direction that they move. We are told that a particle P of mass 2 kilograms is moving under the action of two constant forces, and we're given those as 2I, and we're given those in the question. We're first asked to determine in degrees the angle between the resultant of these two forces and the vector j. Okay, so I'm going to start by calculating the resultant. The resultant comes from adding these two vectors together. I'm going to use column vectors. So that's 2, 3 plus 6, negative 1. And together we get from there 8, 2. So we're dealing with the resultant vector 8, 2. I'm actually going to draw out a diagram of that vector. So this is 8 units to the right and 2 units up. We're asked to find the angle that this vector, the vector is the diagonal line, we're asked to find the angle that that makes with the vector j. And now j is 1 vertical unit up. So the angle we're looking for in this case is theta. Looking at the triangle I've drawn, it's going to be easier to find the angle inside, which is going to be alpha. And I know that these two together should be 90, so I can still solve for theta. Okay, so how do we find alpha? We have the opposite and the adjacent. That means we're going to be using a tan function. Tan alpha equals 2 over 8, or a quarter. So alpha is the inverse tan of a quarter. So just into the calculator, and that gives us an angle of 14.02. So if alpha is 14.02, that means theta is 90 minus that. So 90 minus 14.02 gives us 75.96. In part B, we're asked to find the acceleration of P in vector form. Okay, the best thing to use here is to use Newton's second law. The resultant force should equal the mass times the acceleration. I found the resultant force earlier. It's 8.2. We were told the mass is 2, and we're looking for the acceleration. Rearranging, this means that half of that resultant force should be the acceleration. So the acceleration is 4.1. The final part of this question tells us the initial velocity of P, which is negative 8.3, and we're asked to calculate the speed of P after 3 seconds. So we're going to make use of SUVAT just the way we usually would. We're going to do things in vector form. We don't need to convert into scalars. We actually lose accuracy and will be incorrect if we work in scalars unnecessarily. So the displacement is unknown. The initial velocity was given to us, negative 8.3. We also know the acceleration, 4.1, and we know the time we're working with, which is 3 seconds. All of this should still work in vector form. The equation to use is v equals u plus at. We're looking for v. The equation we'll use here is v equals u plus at. So substitute the vectors, and here we just have a vector equation or a vector expression that we can solve. Negative 8 plus 12, and we're going to get 3 plus 3. So altogether, that gives us 4, 6 as our velocity vector. Okay, so we're actually asked for the speed, which lets us know we should be calculating the resultant, the magnitude of this velocity vector, and we can do that through Pythagoras. So 4 squared plus 6 squared, all square rooted, gets us a speed of 7.21 meters per second.